floor now to Swetha, who's going to talk about some developments in OHDSI India more in depth on what was shared versus what was shared in June last time. Go ahead, Swetha.
Thank you so much. Hi all, and this is our agenda. There's a which is a small overview on the breast cancer study that we are currently doing, and an FHIR work group that we have initiated in India, and the CVD Patient Registry that we have built, and the Digital Health Center of Excellence. We are looking for collaborations. So this is our team. Hey guys, I think everybody is here. Can we see some thumbs up and all here from everyone? Yeah, this is me, Dr. Swetha, and Kanza Fatima, Sai Dilip, Shrima, Sanjay, Pattabhiram, and Vipina. This is our breast cancer study team. So regarding breast cancer study, as we said, Indian data is mostly unstructured and semi-structured data. Even EHRs and the EMRs in place as of now started kicking off, but still we expect a lot of data, even partially 50% of data will be unstructured and semi-structured. So we thought, let us start with applying some NLP technology and text extraction and get some standardized data from that and understand how we can map Indian drug brands and clinical text to UMAP concept IDs, and let us start with it. So we have started with the breast cancer study with the discharge summaries that we have found in JSS Mysore University from 2014 to 2022. Our main objective is to standardize the data, extract with the NLP techniques and convert the data to UMAP standards, and then see if we can generate some kind of real world evidence and generate good studies from there is our objective. So this is our data. This is a small discharge summary, a sample discharge summary, and this is a dummy discharge summary we have placed here. So what we have exactly in the data, we have some kind of demographic information of the patients. That's the age when the patient is admitted. These are all the inpatient discharge summaries. So description of what is the current diagnosis and what are the current symptoms of the patients, what is the medical history of the patient, the labs and diagnoses or the procedures that are performed during the inpatient visit or any past history of procedures done on the patient, and the course in the hospital, whatever treatment was given, whatever drugs are given to the patient, and also advice on discharge summary, like a discharge, what kind of drugs were prescribed to the patient. So this is the basic information we can get out of this and extract. So this is about the data and process overflow, like how we have framed the pipeline or what are the steps we have done along this way. So we have PDFs, so we have directly de-identified the PDFs to remove the patient health information, and then we have converted all the PDFs to text and then manually annotated 500 to 600 discharge summary to create the training data set, and we have developed NLP models for named entity recognition and relationship extraction and concept normalization, and evaluating the model with precision, recall, F1 score accuracy, and UMAP CDM data conversion. These are the process overflow steps or pipeline that we have found. And the first step PDF de-identification, mainly to remove the PHI. This is how we have done that, and we have used a simple redact tool to do that, where re-identification is not possible, and the tool was about 100% able to remove all the patient health information from and this is rechecked by the team in JSS to share us the data with. And then conversion of PDF to text is done with simple Python script, and annotating the clinical notes is a primary task which is done manually. So as a first step, we have developed annotation guidelines. We have identified the main entities. There are five main entities we have observed. That is the demographic entity, the problem entity, procedure, drug, test, and we have described in the annotation guidelines what each entity means. And for example, if we have taken the problem entity, each entity is described with its modifier. Like problem entity, what is the severity of the problem, and what is the body location, temporal negation, like giving no, this is a kind of negative phases, identifying it, and the problem status, like whether it is a current status or the history of the patient. So these kind of modifiers and relations we are able to give in this annotation guidelines. So this is what we have covered in the annotation guideline. That is the basic annotation rules, like what is gender look like in the document, how they have to annotate it, what is age looking like, and how to annotate it, and specific guideline for each main entity with examples we were able to give, and special cases, how to identify the special cases, what are different conditions they have to remember, and the modifiers, almost 25 modifiers we identified and described and given examples, and how to build the relationships. So this is what it is there in the annotation guideline. This is how the annotation look like. We have built an annotation schema with all the main entities and the modifiers. And for example, there is a procedure chemotherapy. It should be manually annotated as a chemotherapy. And if there is a modifier for that, a diagnosis is that LLDC, left breast, and left breast is identified as a condition as well as a body location modifier. If there is a Dirk Bromstall and the tablet is identified as a form, and the strength is 10 mg and frequency and the duration, we have to identify and give relations to that. This is the basic annotation structure we have followed, and the tool we used for this is Meditator tool, and here is the GitHub link, and we have done this annotation in 4 batches totally. So we have maintained a consistent 94% while doing it, and 25, 75, 75 and 125. This is the batches we have released for each inter-annotation agreement actually. So how this inter-annotation agreement works, we are giving here. This is the measurement we have used. Cohen's kappa and Krippendorf's alpha is something we have used, and this is used with Meditator itself. It was able to calculate with that. And if the annotation guideline, we have to follow the annotator guidelines, and then annotation is done. Then if it is good, it will go to the annotated data set. If it is bad, then we have to analyze where we have done wrong, and we will be redoing the annotations. The overall score, F1 score, we are able to maintain 0.88%. Coming to the next step, developing NLP models like named entity recognition and relationship extraction and concept normalization. This is a data extraction from the discharge summaries what we have done, and the named entity recognition, as I said, it is like 5 main entities and 25 modifiers, 25 to 27 modifiers. And with respect to relationship extraction, giving the relationships and all these things we were able to extract with the word model, and concept normalization and vocabulary mapping. We have faced a lot of challenges. Maybe in the coming slides I'll explain how we have done that. And the train, validate, test data ratio is 70, 10 and 20. This is what we have followed. Named entity recognition, we have developed a BERT model mainly to identify the boundaries of entities and thematic categories of the entities. We have followed the bio-tagging, beginning, inside and outside tagging, and I have attached a screenshot how this tagging is done for a demographic entity for more clarity. And for example, the evaluation is done if there is breast cancer. The breast cancer should be identified completely as such as PI, then it is an exact match. If it is cancer, the cancer is only identifying, then it is a relaxed match. And if breast is identifying as a body part, it's not a match. That's how we are able to evaluate it. And then relationship extraction. This is also done with the BERT model, mainly to identify the thematic relationship and context of the relation. So carcinoma breast, it has an attribute related to that. And bronchopneumonia, which is a final diagnosis, it has an attribute. So the relationships, whatever we have manually given, the model has to be identifying that. So this is the evaluation part. The red line represents the drug has a frequency, and the blue line represents negative. There is no relationship with it. And for concept normalization and vocabulary mapping, this is work in progress. work, I would say. So the entities, whatever we have received from NER and the relationship extraction, we are generating synonym generation models, mainly to reduce, like for example, carcinoma of breast, breast cancer, cancer in the right breast, cancer in the left breast. There are many context used, synonyms used while writing the discharge summaries, because it's from 2014 to 2023. There are different variations of that. So we are even able to use Elasticsearch. We have built a tool which is like a medical mapping tool, mainly for the Indian context, where we are able to identify these synonyms or normalize it and do manual validation, like depending on the frequency, like something like SAGI, and we can validate it and give a concept ID to this. So give a concept ID to this. So this is what we have done, and so this is a concept normalization for clinical texts and drugs. We have used UMLS API, where manual validations we made sure we have done for each vocabulary mapping or clinical node, and then converted it to UMAP concept ID. And the main dictionary we have used is UMLS. And then for drugs, we had an ISO SNOMED work group 6, where they are building like mapping all the Indian drugs to SNOMED codes. So we are able to identify the flash files, and also we are connecting with UMLS, and we are converting these brands to the generics, where if it is the direct brand is not available in the RX now, and we have converted it to UMAP concept ID. So this is about the medical mapping tool that we have told. We are trying to train 2 lakhs drugs from Indian data, that the brand names should be converted to generic composition, and like this will map like UMLS, RX norm, and SNOMED CT, whatever the clinical text, or it can be Indian brand names to the generics. And we used Gemini AI in this, and like the manual reviews and auto spell checks, the abbreviation recognition, all this is possible with the large data sets. So this is a small input I have attached how this tool works. For example, the drugs, some short drugs I have tried to upload in this tool, and this, after doing the manual like validations, this is the output we receive. It will map it to CUI, and the source code, it will map it to RX norm as well. This is the output from the tool. Coming to the last step, OMAP CDM, these are the tables we assume that we convert the data to, and maybe in another 2 months I will give an overview on what scores we were able to achieve, what is the evaluation results. And these are the tables like person table, measurement and conditions, and observations with SNOMED CT, and drugs with RX norm, and the node table. So what we have learned in this complete exercise, it's like de-identification and like text extraction of the 5 main entities, and 25 modifiers extracted, like temporals and the drug frequencies, doses, and different kinds of diseases, diagnosis, and contextualizing the past versus the current condition depending upon the discharge summary date, and mapping mainly the Indian drugs or clinical text to UMAP concept IDs. And we were able to build a tool not only for the studies, even we are building future studies, it would be easy for us to convert the data. So the realities of research, or the challenges what we have faced, what are we going to? So the primary thing is very stringent data privacy rules. The data partners are not open. Even though we have almost 180 people in our team, such as OHDSI India collaborators, and many people are coming forward to help us in studies, we are able to use all the collaborators, because the data partners are not open completely because of the data privacy laws, to even as the federated nodes or placing the data in cloud and building these models. It is very tough for us to convince the data partners. So a very small team is working for all the complete work, and we are able to predict the infrastructure needs, because NLP needs a huge infrastructure, and we are not supported by any of grants or anything as of now. And the GVW is our own source of kind of financing our budgeting our needs. So this is very tough to get approvals, and this takes us some time to get it done, and it is resource intensive. As I said, we are a lean team. You have seen our team, and manually annotating and mapping the vocabularies is very tough for us. We need a lot of resources for that, but we are doing with a small team. We are doing it, and Indian drug data mapping mainly with the brands to the RX norm or generic is a tough task, but still we are trying to convert that at least 2 lakhs drugs. We want to do that in that way. That's our aim to do. So the next steps from this breast cancer study, we want to do a publication out from this study, and then automate the process. For sure, we are going to get unstructured data and semi-structured data even in future. For few years, we expect such kind of data from Indian hospitals. So we want to automate some kind of process at least in between, and to give JSS and some more researchers access to the converted data and see how Atlas is working with our kind of data and opportunities. Mainly for breast cancer data, we want to see some networking and collaborative studies to increase the data set size, and we want to train and expand our medical mapping tool for wider community use. So these are our next steps with respect to breast cancer data, and these are few preliminary research questions we thought to apply for once the data is converted. A simple characterization study with demographic profiles, common comorbidities, procedures, drugs and tests, whatever entities we are able to extract from, and the treatment patterns, and the predicting the length of the stay of the patient, and also a baseline demographic and clinical features predict whether patient will complete more than 6 chemotherapy cycles, because we see a lot of cycle numbers over the discharge summaries we would like to see. But the important research questions will come after our first characterization study. We will understand what data is there, what we can do further with it. So this is one more initiative that we are building in India. So FHIR work group, we have collaborated along with the HL7 team. Kumar Satyam is a person who's chairing the HL7. We have collaborated with them, and Dr. Chandal, who's a co-founder at SBM Hospital, Manish, a founder in Yazur Healthcare, Parthiban, we all know Parthiban, and Swetha, it's me. So we are trying to build some kind of ABDM FHIR, Ayushman Bharat Digital Mission. We have adopted FHIR, but it is something not really the complete FHIR. We have tweaked it for our needs actually. So we want to map that to UMAP conversion and see how far the global FHIR guidelines can be adapted. And we want to do a small study or small kind of exercise on that. And advanced capacity building and community engagement is something we are looking for. And there are almost 2,000 current HL7 team they are. So we are expecting a good number of collaborators along with that. These are all current collaborators. We are going to form a very good work group is what our thoughts are. So this is about FHIR. And the second initiative is the CVD Patient Registry that we have built. As we are evolving and into the digital mission currently, patient data collection itself, it is a kind of, we want to see by building an OMAP competent patient registry and see how we can build a longitudinal database collecting only for CVD for a particular department, because this department the patient's inflow is more in different hospitals. So CVD, and it's a therapeutical area where the national interest is also there. So we have built a registry. You can see on the image like demographic information, the diagnosis, drugs, the procedures, everything can be noted here. And we have applied some predefined fields where it is coded automatically to the medical dictionaries we have integrated. And then we are trying to convert to automate the process of home conversion. And we want to build a capability of ABDM FHIR readiness. Phase 1 is ready for it to release, and phase 2 will be with the FHIR ABDM readiness. So this is about the CVD patient registry. As of now, this will be for release, and we want to extend it to other therapeutical areas as well. So this is the other initiative, that is Digital Health Center for Excellence. As I said that India is moving towards the digital mission. ABDM is an important structure that we are building in, and we want to align with the national interest. We want to know what's exactly happening, and we want to unlock the potential of large scale health data in India to enable the RWE studies. So with this aim, along with Ashoka University, Rintu Kutam is one of the person who is supporting us, Parthiban and me. We are trying to collaborate and form a COE with various hospitals, identifying and understanding their needs, and maybe different aspects we would like to bring, and mainly to see some fundings and grants from the government and other aspects to see how we can go through that and gain some grants and mainly money for OHDSI India. So this is our journey, and please join our India chapter to support us. And we have our LinkedIn, YouTube, and we are active there. Looking forward for more questions. Yes, please. We are done with this.
Thanks, Swetha. I hope you didn't rush through. You're right on time. But yeah, I hope you didn't have to go through quickly just to meet the time. Any questions for Swetha around the news from India? I have a few questions, Swetha. So in general, so for the breast cancer one first, right? In general, you're using various models available to somehow extract relevant information from unstructured data to make those data available for conversion into the OMOP aspect, right? So you did address a lot of the data cleansing phases on cleaning up the data from unstructured notes. I guess my question is how straightforward is so you've extracted the relevant information that you need to populate a OMOP common data model, the data model itself. How straightforward is that conversion to the OMOP data model? Have you not reached there yet, or is it working well? I guess is my question.
It is working well. We are almost done with the named entity recognition, and also the relationship extraction, and 85% model performance has done with NER. And for relationship extraction, it is 75, and we are trying to improve more. And with respect to this concept normalization, our tool is working very good, but we are trying to build a kind of automatic model in between, so that the last option will be it's like a layering. We want to try some 2 layers. First will be a model built, and then for concept normalization and synonym identification, and then we will use the tool what we have built to normalize it. That's where we are. We are in the 3rd step, I would say, and then OMOP extraction, but ETL scripts are parallelly we are writing, and then maybe another 2 months is what we are expecting it to complete and come up with some results.
Cool, sounds good. I have other questions, but I'll open up the floor. Nicole, over to you first.
Yeah, just well done, Swetha. That's a lot of work. Congratulations. Maybe I missed it, and I apologize. Are you thinking of also, because you're using the breast cancer example, are you also populating the oncology extension part of the CDM, or is it just the CDM? Yeah.
As of now, it is just the CDM that will be we are aiming to, but we are planning to do the extension as well.
Okay.
That will be our second stage, I would say.
Yeah, that would be amazing.
Our expectation is, please let the data be in OMOP structure and see what we can see from there is our excitement.
Yeah, fabulous. Great. Thank you.
Thanks, Nicole. Cynthia?
Yeah, really nice work.
Hi,
Swetha. Yeah, this reminds me of some work that I did a few years ago with trying to extract adverse drug reactions from, unstructured notes, but the best we ever got was 75%, so the 90% inter-observer agreement is fantastic. And I guess, is that because you have the help of an AI engine?
No, you're asking about IAA? interannotation.
But didn't you have like 95% or 97%?
That is for interannotation. 95% is for our interannotation agreement, and NER and the other relationship extraction, NER is at the range of 85%, and relationship extraction we are at 75%, and concept normalization, our tool is recognizing 70% at this time, but we would like to train it more and make it more improved version.
Yeah, well, I realize how much labor intensive. I mean, I think you went over it very quickly, but there's a lot of labor that's in here. Congratulations.
Thank you. Yeah.
All right. Any other questions for Swetha? Right, we're 2 minutes past. Thank you, Swetha, again for coming on to give this great update. Very good to know.